Show that the geometric sequence with the first term 3 and seventh term 1 out of 243 has two possible sums to infinity and find them. So suppose the first term is a1 and that would be equal to 3, and r is a common ratio. Then we can write the second term as 3r and the third term as 3r square and the fourth term as 3r cube, and so on. The seventh term would be 3r to the power 6. Now we've given the seventh term is 1 out of 243, so we can write a7 equals 3r to the power 6 equals 1 out of 243. So therefore r to the power 6 is 1 out of 3 multiplied by 243. Now 243 can be written as a power of 3, that is 3 times 3, 9, times 3 is 27, times 3 is 81, times 3 is 243. So that would be 3 to the power 1, 2, 3, 4, 5. So I can write this as r to the power 6 is 1 out of 3 to the power 6. Therefore r would be plus or minus 1 out of 3. Because if you had r is minus 3 minus 1 out of 3, then r to the power 6 would be 1 out of 3 to the power 6. You know, it's an even power. And we could also, and obviously have r equals plus 1 out of 3. So when we do r equals 3 or 1 out of plus or minus 1 out of 3, you would get different sums to infinity. So r equals, if r equals 1 out of 3, sum to infinity would be a out of 1 minus r. Now a, or in this case a1, so a1 is 3 out of 1 minus r is 1 minus 1 out of 3, and that equals 3 minus 1 is 2. So 2 out of 3, so it will be 3 times 3 out of 2, and that is equal to 9 out of 2. So that's one possibility. The other one is if r equals minus 1 out of 3, what would happen? So if r equals minus 1 out of 3, you would get s infinity equals, similarly, it would be 3 divided by 1 minus 1 out of 3. So that would be 3 out of 1 plus 1 out of 3, and that equals 3 plus 1 is 4. So it will be 9 out of 4. So our two answers are 9 out of 2 and 9 out of 4.